This video lecture is for BSc 3rd semester of Physics of Mysore University. Dear students, in this session, I will discuss about derivation of expression for current when AC is applied to LR circuit, calculation of impedance of LR circuit, discussion of frequency response of LR circuit. Before going into the discussion, let us recap what we have learned in the previous class. We learned about the representation of AC as a complex exponential function using J symbols, lead and lag of voltage and current, expression for current when AC is applied to resistor, that is a pure resistor, pure inductor and a pure capacitor circuit. Following are the prerequisites. Knowledge about response of AC circuit with inductance and resistance. Knowledge about impedance in an AC circuit. Knowledge about variation of current with the frequency of applied voltage in the circuit. Now, let us discuss about the expression for current when alternating current is applied to LR circuit. LR circuit is that circuit in which the alternating voltage is applied to a circuit containing resistance and inductance in series. The instantaneous voltage V is equal to V0 into e to the power j omega t is applied to the LR circuit. So here the potential difference across the resistor is VR is equal to R into I. The potential difference across the inductor is j omega L into I, where R is the resistance of the resistor and omega L is the inductive reactance of the inductor. The multiplication of J implies that potential difference across L leads current by a phase angle of pi by 2. According to Kirchhoff's voltage law, we can write V is equal to VR plus VL for this LR circuit. That is equal to V0 into e to the power j omega t is equal to R into I plus j omega L into I. Then we can rewrite the expression as the current I is equal to V0 into e to the power j omega t divided by R plus j omega L. For simplification, let us substitute R is equal to Z cos phi and omega L is equal to Z sin phi, where Z is the impedance of the circuit and phi is the phase angle between applied voltage and the current flowing in the circuit. After simplification, we get the equation I is equal to I0 into e to the power j omega t minus phi, where I0 is the peak value of the current flowing in the circuit that can be given by V0 by Z. If V0 is the peak value of the voltage, we get the I0 as the peak value of the current. For the applied voltage, V is equal to V0 into e to the power j omega t. We get the current I is equal to I0 into e to the power j omega t minus phi. Therefore, from this expression, we will come to know that the current lags with respect to the EMF, that is applied voltage. Now we can calculate the impedance of the LR circuit. Impedance is nothing but the opposition offered for the flow of current in the circuit when there are components like resistance, inductance, capacitance in the circuit. The impedance of series LR circuit or RL circuit is nothing but the combined effect of resistance and inductive reactance of the circuit as a whole. Resistance is the opposition offered by the resistor in the circuit, and in the same way inductive reactance is the opposition for the flow of current offered by the inductor in the circuit. Impedance can also be defined as impedance in any circuit is the ratio of the effective voltage to the effective current. The impedance of series RL circuit is given by Z is equal to square root of R square plus omega square L square. Hence the complex value of the impedance is given by Z is equal to R plus J omega L. From the above equations, we come to know that there is a variation of the response of the circuit with the frequency. The frequency response of a circuit is the variation in its behavior with the change in signal frequency. Hence, in an LR circuit, the following are the responses. The resistance is independent of frequency. Inductive reactance is directly proportional to frequency. Total impedance Z increases with frequency. Phase angle phi increases with frequency.